So welcome back again to my physics O level videos, and today we continue with current electricity. But today I'm going to first of all start by looking at some sample questions based on the concept that we had actually put up the last time. Then I'll pick it up and highlight some further concept under current electricity that you need to know. Now, just to give you a heads up from what we discussed, we did talk about what electric current is, and I did say that electric current is simply the flow of charge per unit time, or you can simply say the rate of flow of charge, and therefore we simply say the formula is electric current I is equal to charge divided by time. And of course, we went on further and looked at what charge is, and I did mention that charge is simply the number of electrons passing a point per unit time. When I say per unit time, I mean in just 1 second. So making Q the subject of the formula, you are going to have charge is equal to current multiplied by time, or charge is equal to it in this case. And remember, the SI unit for charge is coulombs, the SI unit for electric current is ampere. Then of course, for those that are doing pure science, I went further and highlighted the concept, which I did mention to say that 1 coulomb, we did say that a coulomb is simply the charge carried by 6.25 times 10 raised to the power 18 electrons. And therefore, we did try to find out what 1 electron is. We did say 1 electron is equal to 1.6 times 10 raised to the power negative 19, and this was in coulombs. So these are concepts that you still need to remember, to look at. Now let's dwell and look at these sample questions and how you can go about them. So I'll simply clean up this concept. I just wanted to remind you from my previous video. In case you didn't watch the previous video, please, you can fall back and actually watch those concepts. So the first question there, question number 1, simply says a current of 5 amps flows through a conductor in 2 minutes. Then it says calculate A, the quantity of charge in this time, then B, the number of electrons in the charge in A above. So what information have we been given in the question, the data that we have been given? Well, the question has actually given us the current. So they have given us the current, which is 5 amps. And they have also given us the time through which the current flows, which is 2 minutes. But remember, this is not the SI unit for time. The SI unit for time is simply the second. So you need to ensure that you convert. Using the conversion, 1 minute is equal to 60 seconds. So what about if you have got 2 minutes, then how many seconds? In simple terms, if you are converting minutes to seconds, you just multiply that by 60. So when you multiply that, my time is going to give me 120 seconds. In the first question, in the first part of the question, it is asking us to find the quantity of charge. So the question is asking us to find charge, which we don't know. So what's the formula that we can apply to find the charge? Remember, charge is equal to current multiplied by time. Therefore, charge will be equal to how much is the current? It is simply 5 amps multiplied by the time, which is 120 seconds. Please remember to convert your time to seconds. Therefore, my charge will be equal to, using a calculator, 5 multiplied by 120, that is going to give me a 600. Remember, 5 times 12 is a 60, and another 0 and coulombs there, which is a capital letter C. So this is the way you can go about answering the first part of the question number 1. In the next one, it says we calculate B, the number of electrons in the charge in A above. So in this charge, how many electrons are there? That's what the question is saying. So we can actually get to do the question from this side. I'll use a different marker so that you're able to see. If you remember, we mean that 1 electron is equal to 1.6 times 10 raised to the power negative 19, and that is in coulombs. So now they are saying, suppose I have this 600 coulombs, then how many electrons will there be? And therefore we can cross multiply. So if we cross multiply, there it is going to be x is equal to, let me just try to clean up the space so that maybe someone does not get distracted with that. So when we cross multiply, it is going to be x multiplied by 1.6 times 10 raised to the power negative 19 to the power negative 19, which is equal to 1 times 600 will give me a 600. And how do I find in this case, my x there? I'll simply divide 1.6 times 10 to the power negative 19. What I do this side, I'll also do it the other side. So 1.6 times 10 to the power negative 19. So this and that will cancel. I'll remain with x is equal to, if you were to put that on your calculator, 600 divided by 1.6 exponent negative 19. It is giving me a value, if you are doing it on your calculator, it is giving me a value of 3.75 times 10 raised to the power 21, and this is going to be electrons. So meaning that in 600 coulombs we have 3.75 times 10 raised to the power 21 electrons. So that is how you can go about the first question. Well, let's move on to question number 2 and try to see, how we can do that. So let's move on to question number 2. So for question number 2 there, because of my space, that's why I'm actually erasing that. For question number 2, it says find the amount of current, flowing through a torch if 6,000 coulombs of charge flows in 4 seconds. Again, what information do we have in the question there? They have given us that, which is the charge, so which is a 6,000, coulombs, and they have given us the time in which that charge, passes, which is actually 4 minutes. If you remember, you convert the minutes to second, you just need to multiply by 60 seconds. So what will that give us? That will give us a 240 seconds. So now what is the question asking us to find? The amount of electric current. So the question is asking you to find the current which you don't know. From the formula that we established, remember we said current is equal to charge divided by time. Therefore, current will be equal to the charge, which is 6,000 coulombs, divided by time, which is 240 seconds. Therefore, I can simply say when we divide 6,000, if you use your calculator, 6,000 divided by 240 is giving me a 25. So there it is going to be, remember the SI unit is simply, amps. So that's okay. Another one might have said, okay, fine, I want to express it in coulomb per second. Well, that would have been okay, 25 coulomb per second. That's what we mean, coulomb per second. That could be another way of you expressing that. So that's the way you can go about, the second question. I hope you are following. It's always good to list down the data. Make sure you convert your minutes to seconds by multiplying by 60 seconds. Then it will be easy. Then you can replace it in that formula. Very important. Okay, let's focus now our attention on the third question that we have there. It says, how long would it take? So this question is asking us, how long would it take for a charge of, so if you notice for question number 3 there, according to the data that we have, how long would it take for a charge? So they have given us a charge of 1,200 microcoulombs to flow when a current of, so they have also given us the current of 0.01 amps is flowing in a circuit. So they want how long, so they're asking you to find the time. Now if you notice, this has been given in a smaller unit, microcoulombs. So we need to convert that microcoulombs to the SI unit for charge, which is just the coulombs. So what you can do, remember 1 microcoulomb is equal to 10 raised to the power negative 6 coulombs. I hope you remember from the prefix that we discussed in this case. So in simple terms, this value, it's the same as actually just multiplying it in this case by 10 to the power negative 6. So just multiply this guy by 10 raised to the power negative 6. So the moment you multiply by 10 to the power negative 6, it simply means you convert it. So it is going to be 1200 times 10 to the power negative 6 coulombs. That's what it simply means there. All right, so what's the question asking us to find? Time. Well, according to the formula, if you remember, current is equal to charge divided by time. Now, since we are finding the time there, you can just exchange that. So it will be time is equal to charge divided by current. That's what we mean. So it's the charge divided by the current. So what's the charge? It is 1200 times 10 raised to the power negative 6 divided by the current, which is 0.01. So remember, that is in coulombs and that is in amps. So therefore, what would be the time? Well, using your calculator, you can actually just punch it. Well, if you calculate that on the calculator, 1200 exponent negative 6 divided by 0.01, it is actually going to give us our final answer 0.12 seconds. So that is what we mean. So this is the final answer, how long it would take, in other words, for this charge to flow in that for this amount of current when it is passing through the circuit. All right, so this is how you can actually go about question number 3 in particular. So question number 3 in particular and question number B in particular is much common in those that are doing pure science, but you can actually look at it because you are going to be looking at other concept. All right, so just on that electric current, remember what I told you. Even if we are doing science, we did say that the SI unit, in this case the SI unit for electric current is what we called as being the ampere, capital letter A. But sometimes they can express it in other smaller units, like I said, where you can use what we are calling MA is equal to, so that is MA is representing milliamps. So when you have been given milliamps, 1 milliamp is equal to 10 to the power negative 3 amps. You need to remember that. So they can ask you, just like we did under what we called as being micro. Like I said, 1 microamps is equal to 10 to the power negative 6 amps. So these two conversions are important, because each time, if they give you in milliamps or microamps, make sure that you convert to amps, so you can use these standard conversions. Now at this point, I can simply talk about what we are calling as being the potential. So I can talk about the potential difference. So I can talk about the potential difference, which is represented as the PD. So what exactly is potential difference? Well, potential difference, imagine that we have what we are calling as being a conductor, such as a wire. In that conductor, there are electrons that are moving in it. So if I say this is A and that is B, when electrons are passing a particular point in a unit time, that creates what we call as being a charge, and the flow of that charge forms up what we are calling as being an electric current. So what exactly is potential difference? Well, potential difference is the work done in moving a charge between 2 points, for example, between point A and B. So how much work is done in moving a charge between 2 points? That is what I call as being potential difference. Of course, different books may define it in different words. So we can simply say that potential difference is the work done, like we said, so is the work done in moving, so the work done in moving a charge between 2 points. So the work done in moving a charge between 2 points, that is what we call as being potential difference. So, and remember, the potential difference is sometimes represented as the voltage. That is what you need to remember. So what's the formula here that we are going to be dealing with? Well, we can say voltage, like I said, potential difference can be represented as voltage, which is my PD. My potential difference is equal to what we are calling as being the work done, divided by what we are calling as being the charge. But you need to remember that work, as we taught you under work, energy, and power, is that work is a form of energy. So I can say voltage is equal to, or potential difference is equal to, the energy divided by what? Divided by the charge. That's what I can say. So this is the formula that we can use to calculate the potential difference. If we know the energy and the charge, we can do that. But what is the SI unit for potential energy? Well, the SI unit is simply the volt, which is represented by capital letter V. Now, suppose you don't find that. Remember that energy is measured in joules and charge is measured in coulomb. So combining that, we are going to have joule per coulomb. So what's the relationship between a volt and joule per coulomb? Well, the relationship is that 1 volt is the same as 1 joule per coulomb. So that's the relationship that you need to remember. So sometimes you may not find joule, or we can ask you to define, to define a volt. A volt is simply, we can say, the work done, in 1 joule per coulomb. That is what we can simply say there if we were to define it. Now, allow me just to highlight a few concepts. Using the same formula. So I'll clear up this section here so that I can actually get to highlight for you a few concepts that you need to remember. Don't worry, we'll try to use that. A few concepts and formulas that you are going to be using. So we are saying that voltage or potential difference is equal to the energy divided by the charge. We can make E the subject of the formula, and when I do that, it will be E is equal to voltage multiplied by charge. So you can say over 1, then cross multiply. This times that will give you E, this times that will give you that. So you can calculate that E is actually representing what we call as being electrical. So this is, you can call as being electrical energy. So electrical energy can be calculated if you know the voltage and the charge. You can calculate the electrical energy. Let's see how else we can calculate the electrical energy. So E is equal to VQ. But we also know so far that charge is equal to IT. So where there's a charge, I can replace with the IT. So meaning that electrical energy is equal to voltage, current times time. So this is, we can say, another formula that we can use to calculate, electrical energy. What else? Let's try to, go further. E is equal to VIT, but also we know that, power is equal to voltage times current. If you remember from what we taught you previously, concept, power is equal to voltage times current. So meaning, where there's VI in my formula for electrical energy, I can replace with power. So electrical energy can be your power multiplied by T. And this is my third equation. We can go on and derive other equations in relation to the 3 that I've derived. But remember, this one is also one of the famous formulas that we are going to be using later on to calculate the cost of electricity. What else can I actually talk about? Well, before I move on, let me, come to what we are calling as being, Ohm's. Let me just highlight on what we are calling as being Ohm's law. Let me try to highlight on Ohm's law. What does Ohm's law, state? And that's the question they are going to be asking you. State Ohm's law. Well, according to Ohm's law, it states that, Ohm's law states that the potential difference in a conductor is directly proportional to the current at constant temperature. So we can simply say Ohm's law, states that the potential difference across a conductor, in this case a conductor is a wire, a material that allows electrons to pass through it. So the potential difference across a conductor is directly proportional to the current at constant temperature. Right, at constant temperature. So mathematically, we are going to highlight how that is going to be. So we are going to highlight mathematically how that is going to be in my next video. See you in my next video.